All right, everyone, let's get back to business here. So just to make it official, the bonus number 60, I'll give you till Tuesday if you want to look at it over the weekend. I know it's Halloween weekend, but well, I guess is it? I mean, I know it's tonight, but I'm saying like a lot of Halloween parties this weekend. Yeah. Yeah, it's a weird one. It's like you can do it both weekends, right? You could just do them both. All right, let's get going. We got a lot to do today. Geometric series is what we talked about last time. That's what a geometric series looks like, right? I gave a handout last time. Anybody need it? I think I have a couple of copies. Anyone need this handout? Do you mind coming and grabbing it? I'm all wired up here. I forgot to tell you I had this handout when you emailed me. There you go. Yes. How many pages? It should turn out to a geometric series. And then from there it should be, you just have to come up with the formula that will give you the geometric series. And the formula is the part that requires the most work. Okay, so this is what a geometric series looks like, right? It converged if what? Which one is less than 1? R, right? Okay, so last time we looked at just if R was positive, all right? But I want to generalize this to match a handout that I'm going to give you all later today. This converges if the absolute value of R is less than 1. It diverges if the absolute value of R is greater than or equal to 1. So that means it doesn't matter if it's a positive or negative number, if R is a positive or negative number. As long as the absolute value of it is less than 1, this will converge. And what does it converge to? If it does converge, where does it converge to? Like, what's the answer? What's the infinite sum? That's what each term is going to 0, but what does the sum add up to be? S, which is A over 1 minus R. There we go. That's what I was looking for. All right, that's what geometric series look like. Now, I want to point something out. A lot of books will not use a K down here. They'll use a different letter. They'll use N. Now, the reason why I don't like to use N is because I like to reserve N for when we were doing nth partial sums. And my N was I would stop at the top being N, right? Remember, I go K equals 1 to N. Well, if I'm already using N on the bottom, then I have to use something else on the top. So I reserve N strictly for the nth term, the nth partial sum. So on a formula sheet that I'm going to hand you today, it's going to have this instead. But it's the same exact formula, using N's instead of K's. All right? We call this our index, and it's a dummy. We call it a dummy variable. It could be N, it could be K, M, L. There's common indexes that we use. I, J, K, N. So just FYI, if you see these in other books, you'll know that don't freak out that it's not a K. Something else I want to show you. Another formula you may see for geometric series may do this, may be like this. What's different here? Starting from 0 instead of 1. But what else is different? It's r to the n, not r to the n minus 1. That creates the same exact series, though. List them out. Start at n equals 0 instead of n equals 1, and what would you have? What would your first term be? A times r to the 0 is 1, right? So plus, now let n be 1. So you get ar, and then ar squared. How can they? Well, that's where things start to get a little bit weird, because when we talk about a sequence, right, we always said that we start with n equals 1, right? But sequences, when you step out and you start looking at series and just in general sums, you can always start a sum with any index you want, as long as what's in there makes sense. I don't know if that answers your question, but yeah, you're adding them all up. It doesn't change the fact that it's still just a bunch of terms added. So, yes.
So since like n equals 1 is n minus 1, so if n equals like 2 would be n minus 2.
Well, let's look at that. That's exactly what I'm going to talk about next. Can you mess around with this index even more? So let's try something. Let's take this formula in blue here. Okay, I'm going to take that, and let me just mess with this. N equals 1 to infinity, ar to the n minus 1. What if I wanted that to start at n equals 0 instead? Then it should turn into the red one, right? Yes? But how could I do that without knowing the red one? And let me have a systematic way approach to this. What would doing this, get a different color here. Let k equal n minus 1. Oh, wait, hold on. Did I write the right formula down there? Yeah, there we go. Sorry. Change that to a plus. Let k equal n plus 1. So what I'm doing is this. I'm taking that blue one, right here, this blue one, and what I'm trying to do is change the index so that I start at 0 instead of starting at 1. Letting k be equal to n plus 1, let's see what this does. What's k minus 1? What do you get? N, right? So replace all of your n's with k minus 1, and what would you get? Come up to your sum. Infinity. What would this be? What's n? K minus 1 equals 1. A r to the k minus 1 minus 1. What did that do? Look at your bottom equation down here. I can move that, I can add 2 to both sides, or add 1 to both sides. And what would that be? K equals what? 2. Hold on. It's 2, right? If I add 1 to both sides of this equation down here, k is 2 to infinity, and then a to the what? A times r to the k minus 2. So what did that do? How did that change my index? I started at 2 instead of 1. Is that what I wanted, though? I wanted it to go to 0, right? So what could I do to make it start at 0? I'm just trying to show you how you can change a sum. The blue and the red one over there, that's kind of hard to see, it's red, should create the exact same thing, right? Do they? Plug in, start at 2 here. What do you get? 0 up there. plug in 1 here, you get 0 up there. They create the same series, but my index now starts at 2. You can make it start anywhere you want, really, as long as you manipulate this correctly. So let's try something else, because I wanted it to start where? At 0. So let's see if one of you can figure out what I need to, I'm starting over. What do I let k be equal to? N minus 1? Oops, forgot to turn that off. Okay. So if that's the case, then what's n? K plus 1 is n. And now rewrite that sum. I'm out of space, so I'm going to have to write it over here. Sum n is k plus 1 equals n to infinity, and then a r to the n, which is k plus 1 minus 1. K plus 1 equals 1. Yeah, I'm sorry. Thank you. Change that down there. I had put n. So k equals 0. And that's the sum, right? Isn't that the same thing? K equals 0 to infinity, a r to the k 1 minus 1 is 0. So we're just shifting the index around, right? We're just shifting the index around. Now, the drawback to this is that we went from n's to k's, right? So is there a way to go from n's to n's without having to go n's to k's? I'd like to have my series still in terms of n's and not k's. So couldn't I just rewrite that formula and just replace all my k's with n's? To make it n equals 0 and k equals n right there? Okay. I'm giving everyone until Tuesday unless you feel like this is good. Good? Okay. All right, let me try it again. Can you take this? Let's do this one. N equals 1 to infinity, a r to the k. See, I'm so used to using k. N minus 1. Can you start that index at 5 instead? And let's try and do it without using a k. Which is going to seem weird. I wanted to use a k just to show you how you can make things switch. How could you make this right here become a 5? Add 4 to it, right? So if I add 4 to this, I could add 4 to this, right? But then I'd have to take this and do what? Add 4? Will this work? You'll have to include the minus 1, yes. So what we'll get is this. N plus 4 equals 5, and then a r to the n plus 4 minus 1. Does that work? Does just adding 4 to everything work? What are you still getting on the bottom? Yeah, if you move to the 4 to the other side, right? You see why it's hard to do an index switch just right off. You have to have some independent variable in there, like the k, to get everything to switch, and then switch back to your n. It's not easy to just go right from the sum itself. Try it with the k. See if you can come up with this. What would I have to let k be? N equals 5. Where are you saying n minus 5? N equals 5. You're saying for this. And then what? n minus 5.
I mean, can you just switch it like that? Like the 1 is 5.
No. Yeah. No. You can try it. It won't work. In general, it won't work. If you're this specific formula n minus 1, you may have a special case where it does work, but this one won't. I mean, try it. If you try and just replace this with 5, and you say this n minus 5, it may work for this one, but not like for another series. Like we're going to have 4 or 5 different series that simple replacement won't work.
If you use any number, it would just give you 1. If you add any number, like
Let me back up. Let me erase this. If I use what?
if you add like to n equals 1, right? If you add any integer,
Mm-hmm.
like 1,000, you get 1,001, then you subtract 1,000, then you get 1
That's right.
for any number.
That's right. That's why it won't work to just use n and just add something both sides. So let's do it with the k. How can we get it with the k? Let k equal what? And what? Where did I say I want my index to start? At 5? So what do I need to put here? N minus 4? If you don't like this, do it this way. Let n equal k plus 1. It's the same thing, right? Or k plus 4. I want to add 4 to this index right here, right? I want to add 4 to the 1 down there. So basically I'm going to add 4. Everywhere I see an n, I'm going to replace it with the n minus 4. Does this work? What am I replacing n with? K plus 4. Does that work? I don't think this is getting through to y'all. It should be k plus 4. Well, k minus 4. It should be n plus 4 right there. Look what happened. Look, y'all. I'm going to replace this. I'm going to get this blue out of here. This is becoming a catastrophe now. Sometimes these small topics become the hardest ones. All right, I want that to start at n equals 5, right? If I say, and maybe it'll help if we just say, get this out of here. What would I need to add to this to make it a 5? 4. So over here, next to n, if I had a minus 4, I could add 4 to both sides, right? Yes? So let me try it this way. It's going to be a risk. I'm going to let my n's become n minus 4s. Does that make sense? Everywhere I see an n, I replace it with an n minus 4. We'll try and skip over the k's and see if we can get this to work. If I let my n's become n minus 4s, this sum becomes n minus 4 equals 1, ar to the n minus 4 minus 1. Yes? Now add your 4 to both sides. Sum n equals 5, a to the r, or ar to the n minus 5. Which again, it worked here, but it won't generally work.
Why do you need to add? Because when you have n minus 4, just move the 4 to the other side, then you get 5.
Yes? Why do I need to add what?
4. You get 5.
To get 5? I wanted to start the index at 5.
Oh, you just move. Okay.
Yeah. I wanted it to start at 5 instead of 4. Now let me explain kind of why we need this. We're going to have series later on that start different series that we're going to try and put together, and they start at different places. And so to put them together, we have to make them all start at the same place. So we'll have one series where it's like n equals 2 to infinity, blah, blah, blah. Another one's n equals 4, and another one's n equals 7. And we're going to need to make them all n equals 2 or all n equals 4 or all n equals 7. So we're going to have to be able to manipulate the index before we put them together. Does that make sense? All right. We'll revisit this. I think this one, out of the ways I was trying to explain it, I was trying to avoid just doing that because you're letting n become something, n is not equal to n minus 4, right? N is not equal to n minus 4. So I was trying to go through like an intermediate variable, like a replacement, like kb this and then blah, blah, blah. But I think that one probably made the most sense. That's my instinct, like feeling from you, yeah? Yes or no? Okay. All right, let's move on. Geometric series. So I assigned some problems for homework, right? Any questions on the ones I assigned? I don't ask questions over homework often, but
On one of them, you have to break up the sigma notation and then add them together.
yes. Yep. 16? 17, yeah. I'll do something like 16. Sum n equals 1 to infinity. This is number 16. This was not a homework problem, right? Okay. See, at this point, all the homework that I assigned was geometric series. You knew that going in. So when we look at this as the day progresses here, we won't know that necessarily, that this is geometric. So when I see this, what I first do is I look at it and say, what happens to the inside as n goes to infinity? Where does the numerator go? Infinity, denominator, infinity. Infinity over infinity. So I can't really tell just by looking what the inside goes to, right? It's a L'Hopital maybe. It's not easy. Okay, well, that's all right. Let me try this. Let me split this into two fractions because I have two terms in top, one in the bottom. So it's 1 over 2 to the n plus 3 to the n over 2 to the n. Those have the same exponents. Sum n equals 1 to infinity. How can I rewrite 1 over 2 to the n? 1/2 to the n. See, remember, anytime you have a 1 in the numerator, right? Anytime you have a 1 in the numerator, you can write it as 1 over that number to the n because 1 to any power is still 1. So that doesn't change anything. And then the other one, how can I rewrite that one? 3/2 to the n. That's correct. Well, it's a sum. What can you tell me about this right here? What approaches 0? The sequence of those terms. So 1/2, the next term in the sequence would be 1/4, then 1/8, then 1/16. That approaches 0, yes. But what's its sum? Why?
Because if you add them up, they're going.
This is geometric, isn't it? Isn't that a geometric series? What's A? 1. It's the number in front of the geometric series, in front of the R. What's R? 1/2. Therefore, the absolute value of R is less than 1. That converges. Do y'all understand that? That one piece converges when you add them up. It converges to what? A over 1 minus R, so A over 1 minus 1/2, which is 2. So if you were just looking at the 1/2 to the n and you were adding it up forever, it would converge to 2. But you're adding that to this. And that's also geometric. Isn't it? Now it's geometric with what? A is 1 and R is 3 halves. And the absolute value of R is bigger than 1. And what happens when it's bigger than 1? It diverges. It becomes infinite. So the fact that the first part goes to 2 doesn't matter because the other guy's going to infinity. Do you see that? So the entire thing diverges. Because that was greater than 1. Now we do have a couple of little issues though, technicalities that I didn't really consider here. What's wrong with me saying geometric right off the bat right here? It's not in the form n minus 1, is it? Remember up here, this exponent had to be, these had to be n minus 1s, right? But we saw last class, all that really turned out to be was us doing an n minus 1 plus 1 and peeling off something, right? And that thing we peeled off was just a number. So that wasn't going to change the fact that whether or not it converged or diverged in this problem. So I'm being kind of very loose on the math here, but it's only because I knew that that 3 halves diverged. Had it converged, we would have had to work this out a little more neatly. Let's look at, you want me to do 17 or not?
Can you do 13 as well?
Which one?
13 as well?
Yeah, 13 is a good one. Man. Sum n equals 1 to infinity. 3 to the n over e to the n minus 1. I'm going to go sum n equals 1 to infinity of 3 to the n over e to the n times e to the negative 1. Should I do that? Could I do that? Yes. Now, I have here 3 to the n over e to the n. I can rewrite that as 3 over e to the n. And then e to the negative 1 is the same as e on top, isn't it? Now, is this geometric looking? Is it? Yeah, 3 over e is going to be like our r, isn't it? Is that smaller than 1? Yes. So it's going to converge, right? And there's no other part, it's like the previous problem, that was going to diverge. So I'm going to have to get this to look exactly like the formula because I need to find the exact sum. So I actually need an n minus 1 up here. Pardon me? 3 over, oh, yeah, hold on. It's greater than 1. We're done. I don't know why. I was thinking pi for some reason. I was thinking 3 over 3.14. E is 2.718. So E, 3 over that's bigger than 1. Agreed? And I don't know. I could tell when I woke up today it was going to be a tough day. R is greater than 1, isn't it? And that means this diverges. Okay?
So when we have our R greater than 1, we don't need to put it in the formula, right?
That's right. When R is greater than 1, you're pretty much done at that point. Okay, let me try number 9. Number 9. But I'm going to modify it slightly. How about sum n equals 3 to infinity of negative 3 to the n minus 1 over 4 to the n plus 1. What do you think?
You can fill out, write it as an exponent, effectively store it over n minus 1. And then
Guys, what do y'all think? What do you think? Okay, what are you thinking? I hear you talking, so what are you saying? All right. That's what I thought. Are y'all done talking? Okay. All right.
you can like both the numerator and the denominator, right?
Mm-hmm.
You can rewrite it as 3 negative 3 to the n times negative 3 to the minus 1, and then the denominator 4 to the n times 4.
I agree. So since you have things raised to powers, it's looking like maybe geometric if we can get things to look right. So I like that idea. N equals 3. Now we do have a problem here. Do y'all notice the index? You do have what?
That's what I was asking. I don't know if we have to change it.
Yeah, we're going to have to change the index. If it converges, then we have to make everything match. Okay, is that all right? I don't really need the parentheses around the 4 as much as I need them around the... Y'all agree with that? Okay. Questions over that? So now I can, since they're both to the n power, I can rewrite that as negative 3/4 to the n.
And then you can write n times negative 12.
Yep, 1 over. Right, 3 to the negative 1 is really what? 1 over negative 3? 1 over negative 3?
I put the,
And then, well, the 4 can't come on top because it's on the bottom.
no, we can put 4 to the negative 1 and then multiply.
But it's not to the negative 1. It's to the positive 1.
Oh, okay.
Oh, I see what you're saying. Yeah, but if you move it up and it's to the negative 1 up there,
Same exponents, right?
yes, and then put them together, it'd be negative 12 to the negative 1. So it comes back down. So, okay, so 1 over negative 12. We're all doing the same thing, just different ways. Okay, that okay? Now, I need to figure out if this converges or diverges, so I look at what's inside here. That's my R, right? That R, the absolute value of it, is less than 1. So this will converge. But it must look like the formula. The formula that I have 2 to choose from. I have one formula where was it? Let's go back and look at these. No. These were the main 2 here. Where were they? Right here. Those are the main 2, right? I can start my index at 1, but then I need n minus 1s on my powers. Or I can start it at 0, and then I just need the n's, right? It's your choice. Which one do you want? Do you care? You just want to leave it. You want to go to 0? Just n? Okay. Let's try it and see what happens. Okay, so we're going to try and get our index to go to 0. So how am I going to get my index to start at 0? Going to have to let my n become what? N plus 3. Yep. So everywhere I see an n, I'm going to replace it with n plus 3. What that's going to do, right, is when I replace this with n plus 3, I'll be able to subtract 3 on both sides and make that a 0. But then all the other n's have to get n plus 3s also. Yes? That's a critical step. Sum n plus 3 equals 3 to infinity. Negative 3/4 to the what? N plus 3 times 1 over negative 12. This becomes sum n equals 0 to infinity. Oh man, what am I going to do with that now? Because I want that to just be an n, but now it's an n plus 3. Break it up. That's the same as negative 3/4 to the n times negative 3/4 to the what? Third. Times 1 over negative 12. So I split this up into two pieces, right? And now let me put these together, because this is all just a number, isn't it? Put that all together. Let's figure out what that number is. That's going to be our A, isn't it? It's 27 on top, negative 27, however you want to. Positive after you do division by the negative. So what do we get? 27 over 64? Yes? I need a new page. Sum n equals 0 to infinity. 27 over 64, and bring that out front. Negative 3/4 to the n. It should have been positive because it was negative 3/4 cubed, which stays negative, and then the 1 over negative 12. Everyone got that? We good?
Yeah.
Okay. So A is 27 over 64, and R is negative 3/4, and then you can go and figure out what the sum is. Right? Let's see. What is it?
I think it's not 64. I think it's 27 over 768. Yeah.
Oh, did we not multiply by the 4? Oh, 64 times the negative 12. Oh, we never did that. What is that? 768. Okay, thank you. $768. So the sum should be A, 27 over 768 over 1 minus, now be careful here, 1 minus, so it's actually going to become plus because negative 3/4. Got it? And then figure out that. I'm not going to. So what do y'all think? Geometric? Have we exhausted it, or you feel like you've seen enough geometric at least to mess with your homework? Yeah, this is very different. I would say with the geometric series, you're looking for numbers to powers. I mean, right? You're looking for exponential stuff.
The very beginning,
Yeah.
could we just make 4n plus 1 minus 1 and then put it in parentheses?
Very beginning, make 4n plus 1
And 4n plus 1 minus 1.
minus 1 plus 1.
Yeah, and then group the negative 3 and 4 and multiply by a quarter.
I'm not sure I understand what you're saying. Make this. Is that what you're talking about?
4n plus 1 minus 1.
But-
and then,
But that's not the same as 4n plus 1. Yeah, you'd have to have another 1 added. You're not saying doing this, right, where you're switching yet. You're just saying you could have wrote that as n minus 1 plus 2 and then peeled that off with the 3. Yeah. Could have done that. Yeah. All right. All right, we're going to proceed. All right. So I'm going kind of off of our handout from last time. We're going to talk about harmonic series now. So what I have in the notes says we have sum n equals 1 to infinity of A over N, where A is not 0. This is what a harmonic series looks like. A here is basically a number divided by N. So let's look at what the terms of this, or look at what this series is. Let n be 1, you get A over 1, that's A. Plus let n be 2, A over 2 is A times a half, right? Plus A times a third. I could say A over 3, but I'm doing that on purpose. A times a fourth. And I keep doing that forever, right? Never stop. And the question is, what does this add up to be? Well, geometric series, we had to go through this whole thing, and I proved it on the board last time, why geometric series adds up to be A over 1 minus R. With harmonic series, the question is, does it add up to a number, does it diverge, or is there a special case like we had before? Tell me what the terms are headed towards. Each of these guys, if you take the limit of that, that's a constant, A over N. Let N go to infinity. That A sub N goes to 0. Agreed? So they are getting smaller as you go out. Just like geometric did, right? When R was less than 1, geometric got smaller and smaller, tailed off to nothing. But is that enough to say that it converges? Just because the inside piece, the terms go to 0, is that enough to say it converges? It's not. So there's not an easy way to show harmonic series does this, but I'll try. Do you agree that each of those terms there has an A in it? So let's just pull the A out. Forget the A's even there. And let's just look at what all harmonics would have in common. It would be something like 1 plus a half plus a third plus a fourth plus a fifth plus a sixth plus a seventh. I'm going to go out to 8. Plus an eighth. And it would keep going, right? Yeah? Okay, I want you to focus your attention. You have 1, then plus a half. Look at the next 2 terms right there. What's 1/3 plus 1/4? 7/12. Yeah? Would you agree that 7/12 is bigger than a half? 7/12 is bigger than 1/2? Okay. Look at the next 4 terms. Not the next 3 terms, the next 4 terms. What's 1/5 plus 1/6 plus 1/7 plus 1/8? Get your calculator. What is it? 0.625?
26 over.
What is it as a fraction?
26 over.
You could do it with a decimal also. You would have to get a common denominator here, wouldn't you?
Yeah.
Put them all together and figure out your numerators.
26 over.
TI-89 will do it. I'm just waiting for someone to do it. No? 500 what? Over 840. And that number is also bigger than 1/2. Right? What's half of the denominator? 420, and the numerator is bigger than that, right? So that's bigger than a half? Now, if you go out on a harmonic series and you now take the next, how many do you think? I needed the first 2. That was bigger than a half. The next 4 were bigger than a half. The next, what do you think? It's either 6 or 8. It's 8. Okay? So you take the next 8 and add them together, it's bigger than a half. Then you take the next 16, it's bigger than a half. Then you take the next 32, it's bigger than a half. The next 64, it's bigger than a half. So what you basically have is a series where this whole thing added together forever is bigger than this first guy, 1, plus this guy, which is a half, plus what? A half, plus the next 4 would be a half, plus the next one would be, the next 8 terms would be a half, plus, right? And ours is bigger than this, isn't it? This right here would be bigger than this. This term's the same. This one's the same. But those 2 together are bigger than a half. And those next 4 would be bigger than this half. And the next 8 bigger than this half. So that up there is bigger than all this. But this is just 1 plus a half plus a half plus a half plus a half. What would happen if I just keep on piling 1/2 on top of 1/2 forever? Would it converge to something? No. It would diverge. It would become infinite.
What's the left side? I forgot.
The left side of this inequality is the green.
Okay.
But it goes forever. It's a dot, dot, dot.
Why are you adding halves?
I'm saying
Those are greater.
this right here is bigger than if I had just done this. Do you agree with that? You do agree that that's bigger than that? And do you agree that this is basically becoming infinite? If I take a 1 plus a half plus a half plus a half plus a half forever. Only if it goes infinitely. That's right. What? Yes. Oh yeah, absolutely. Yeah. Yeah, but if you go forever, I can keep tacking another half on. Now I have to go really far out in the harmonic every time it's growing by a power of 2. You know, it was 2, then 4, then 8, then 16, then 32, then 64, and 128. But I've got an infinite number of terms to pull from, so I can keep adding halves as I go. So if this is infinite and that series is bigger, then you have to be infinite also. So the conclusion is that all harmonic series diverge. All of them. Okay? Yep. I mean, yeah, these are the ones you're going to find easy. Okay? So we need to talk about what makes harmonic harmonic, all right? You try and help me explain it. What makes a harmonic harmonic? How is it not geometric?
It doesn't convert to greater than
Well, it's right there. Any? Like what's a harmonica? I don't know. Look it up. I'm not sure. Okay.
It doesn't have an R.
Look, let's look at this example right here. Sum n equals 1, or let's say n equals 4 to infinity of 5 over 3n. Is that harmonic? Okay, why? You can pull out a 1/3. You can pull out even more than that. 5/3. This is the same as n equals 4 to infinity of 5/3 over n, isn't it? So that's basically a constant a on top of n. Or that doesn't matter though. Mm-mm. A can be any number. Just can't be 0. Sorry, can't be 0. Could be negative though. That would be all right. So your denominator is growing by 1. That's what makes harmonic harmonic. You write out your series, you take your a out, and then you have a bunch of denominators that just keep going up by 1. Doesn't matter that I start at 4. For harmonic, no. Okay? For geometric, we always have to get it to look exactly the same when it converges. When it diverges, we don't care. Like when our R for geometric was bigger than 1, we said, it diverges, we're done. But when it converged, we had to get our index to match the formula. Here, it's the same thing. We know this can diverge. It doesn't matter, it starts at 4, because I have an infinite number of terms. Does that kind of make sense to you? Go back to this right here. What if I had started out here instead? Would from here on still be harmonic and diverge? Yeah, because I'd still have half plus a half plus a half plus a half plus a half, right? Forever. So it doesn't matter where I even start on harmonic, it's still going to diverge as long as I go to infinity. Okay? Harmonics are nice, right? Nicer than geometric? Easier to evaluate? There's only one answer. Diverge. You just have to show that it's harmonic. Okay. Now, the next thing on our sheet is what's called the nth term test for divergence. Yes? Oh yeah, right here you could say harmonic. You'd say harmonic, A is equal to 5/3, and it diverges. That's it. You're done. All harmonics diverge. Has to be harmonic. There's nothing. That's it. It just diverges. That's it. It becomes infinite. Because the question is, what does this add up to be? And the answer is it's infinite. It doesn't add up to. It doesn't go to a number like geometric series. Sometimes they go to a number. Sometimes they don't. Harmonics always do. You have to recognize the harmonic, identify it. Okay, now, so the question becomes: look, when we're looking at series, right? When we're looking at a series, geometric and harmonic are the only two we've looked at. The question was, when did they converge? When did they diverge, right? There is a test that you can use for divergence. If you want to see if something diverges, here's the test. Do everyone have this? Yeah? No? The nth term test for divergence. It says, given a series, if the limit doesn't go to 0, it diverges. If the limit of what? A sub n. So the nth term test says this. Let's say I have some series like this. Look at that. Is that geometric? No. Why not? Yeah, geometric, you always have a base, which is a number, and then the n is a power, isn't it? In the exponent. This is definitely not geometric. Is it harmonic? Harmonic, you have to have a number over n. You can't even split this into two, can you? That's right. So, not harmonic. Yes. Well, there's not an n on the 5. Make it a 5 over n? You could, but then you would have like a 3 over 4 plus 5 over n. And the 5 over n would be harmonic, right? But the rest of it is not. So you'd have to determine what would happen if that one piece went to infinity. Look, this is there's a simple answer to this question, all right? It uses the nth term test. The nth term test says, look, given a series like this, take a look at the a sub n. This is a sub n, right? That's the piece inside. Take the limit as n goes to infinity. What is the limit as n goes to infinity of that? It's infinity over infinity, so you do L'Hopital's rule one time, and you get what? 3/4, right? Hopefully we've done L'Hopital enough now that everyone's okay with that. 3/4. What does this theorem say? If you take the limit of what's in there, and you get something other than 0, it diverges. It's divergent. We're done. It just diverges. Not every series is harmonic. Not every series is geometric. Those are just two examples of series, special ones. But not all series have to fall into a specific category, like it must be geometric or harmonic or this or that. So this is divergent, right? It diverges by the nth term test. And that would be the end of the problem. Yep, you need to write it down. Yep. I'm going to hand you something at the end of today. This is the summary of convergence and divergence tests for series. There's the nth term test, geometric series, p-series, integral, comparison, ratio, root, alternating tests. These are the tests that we have to go through. So this is like one of our first ones. So for every problem on a test, you would have to identify which type of series, which test you applied, and why you drew the conclusion you drew. All right, so if we take the limited side and it goes to something other than 0, it diverges. How about this one? That's right. What if you had n equals 1 to infinity of n over n squared plus 1? So we look at that. It's not geometric. It's not harmonic, right? So I try my nth term test. I take what's in here. That's my a sub n. I take the limit as n goes to infinity. Apply L'Hopital one time, and I get 1 over 2n. And that limit goes to 0, which means nothing. Okay? This is the most important part of this test. They call it the nth term test for what? What does it say here? Underline. The nth term test for divergence. That test only gives you divergence. That's all it does. If you get 0, it doesn't tell you anything. This tells you it might converge and it might diverge. The thing is, if it gives you something other than 0, like the previous example, it diverges guaranteed. So this would mean inconclusive. I should say the nth term test is inconclusive. So I don't have an answer yet. We will by the end of chapter 3. I mean, section 3, 4. Hold on. 4? Yeah. By the end of section 4, what you would do in a problem like this is you would apply your nth term test. It would be inconclusive, so you'd move on to another test. And you do it until you get to it. Or maybe you skip the nth term test because you just look at it and you know, and you go to one of your other tests. Okay? Questions? Don't be the person that makes the mistake of going, oh, that goes to 0, it converges, yay. It's not the case. Yes?
So, the series will always diverge or converge, right? There's no possibility.
Those are the two possibilities for a series, convergence or divergence.
The possibility doesn't exist.
Oh.
Doesn't exist.
Of what?
Like,
There's no third option, you mean?
yeah.
That's right. Given a series, it either converges or diverges, one or the other. Yes?
So it can't hurt us to just throw this at.
Yeah, this is always the easiest test usually to apply. Just figure out what's going on. See, think about it. If those if in the red box, if that's headed to something other than 0, like let's say it's headed to 1, then aren't you really just saying I'm adding up 1 plus 1 plus 1 plus 1 plus 1 forever? And that just blows up. If those are going towards a number like 1/3, then it's going to blow up. But if it's headed to 0, well, it could be like a harmonic and it's going to 0 but slow, so it still blows up. Or it could be geometric where it's heading towards 0 so fast that it converges. So this test is just able to tell you, hey, look, if the terms aren't going to 0, it's going to diverge. Make sense? All right. We're on the last page of this handout. We're going to talk about one of my favorite topics for series, collapsing or telescopic series. Here we go. I'm just going to do this example. Sum k equals 1. I switched to k. Is that all right with you? All right. 1 over k plus 5. K plus 6. Sure. You want to try it? Well, it's not geometric, right? Is it harmonic?
Yes, I think it is. You have a number over n.
Yeah, but I have another one right next to it, right? Being multiplied.
You have n squared plus.
Yeah, see, you have the ends. It would be like the k squared, and so it wouldn't be harmonic. By itself, right? If I get rid of this, that would be harmonic, right there. That would be harmonic. But the fact that I came in here with k, what is it, plus 6, it's no longer harmonic. Great question. Can you do this? Sum k equals 1 to here, 1 over k plus 5 times sum k equals, is this what you're kind of referring to? What do y'all think?
Can you do that?
Do you think that that's a property of sums?
I don't know. I don't think so.
You don't think so?
I don't think so.
This is an interesting question. Can I hold off and we come back to this? Okay. Just remind me because I want to show it. So this right here, I'm going to kind of save this. If that were the case, though, let's just say that property was true. That first series would do what? Diverge, go to infinity, and the second one would also diverge, right? Because they're both harmonic. And it would make sense that if you take something that diverges, goes to infinity, another one that goes to infinity, and multiply them, that should go to infinity, right? Right? I mean, doesn't that make sense that that would happen? What's your question? No? The what? Yeah, no, that wouldn't be, yeah, can't do it that way. Okay, so this is a question mark. We'll come back to it. Not geometric, not harmonic. Let's do the nth term test. Okay, nth term test. Now, for us, it's not n, right? It's actually k. But I'm going to be doing the limit. K goes to infinity. The kth term test. Limit k goes to infinity. Oh, yeah, it's going to be inconclusive. Because what does that go to? 1 over infinity goes to 0. Inconclusive.
Can you just do this limit?
Do what?
Do the limit?
Do the limit?
You have to multiply, right?
You don't have to. If k goes to infinity, what's infinity plus 5? Right? Okay. Then times infinity again. Infinity times infinity, infinity. 1 over infinity goes to 0.
Infinity times infinity determinant.
No, infinity plus infinity. Or minus infinity, sorry. Infinity minus infinity is indeterminate. Is that all right? Inconclusive. But this is now a new type of series. It's really odd, okay? Let's first write out some of these terms, all right? Let's just write out some terms. Let's let k be 1. If k is 1, what do we get? 1 over 6 times 7, right? Which is 42, but I'm just going to write it like that. Plus, what's the next one? 7 times 8 plus 1 over 8 times 9. Y'all see what's happening here? Not a whole lot of anything, right? Hey, it's just we're adding up these things, right? 1 over 42 plus 1 over 56 plus 1 over 72. They're getting smaller. They're going to 0. We know that, but we also know that with series, them going to 0 doesn't tell us anything, right? It's not enough information. Anybody recognize this? Something we did with integrals when we had that? Partial fractions. Remember partial fractions? Yes? Let's do partial fractions on that. New page. Let's take 1 over, you thought that would never come back, huh? Let's do partial fraction decomposition on this. Now this is one of the easier cases for partial fractions, right? Because you have 2 linear and they're non-repeating, so the algebra involved in solving this is a lot easier than like the one on the test. 1 equals a, k plus 6, plus b, k plus 5. And now I have control over k, so I can kill off things. Right? I'm going to let k be negative 5. And that gives me 1 equals a times negative 5 plus 6, which means that a is 1. I'm going quickly through this because I'm assuming you did enough of this at some point. If k is negative 6, we get this, which means b is negative 1. Okay. Good? That means I can rewrite it as 1 over k plus 5 and then plus negative b. So how about minus 1 over k plus 6? That's our partial fraction decomposition, right? Do I have any questions? Let me go back to my series then. My series now looks like this. Sum k equals 1 to infinity, right? Of 1 over k plus 5 minus 1 over k plus 6. No dx. That's what it looks like. Now, each one of those is harmonic, isn't it? And we would get, if we did break it into two sums, which I don't know if we can do. I'm saying you don't know if you can do that. You would get infinity minus infinity, wouldn't you? And that would be indeterminate. But check this out. Look what happens if you start writing out the terms of the sequence or the series now. Watch what you get. So let me first plug in 1. If I plug in 1, what do I get? 1/6 minus 1 what? 1/7. That's what I get, right? Plus, now plug in 2. You get 1/7 minus 1/8. Plus, what would you get? Now plug in 3. 1/8 minus 1/9. Plus dot, 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 dot forever, right? You see what's happening? You have this negative 1/7 and positive 1/7 canceling. That's right. What's happening is that you have the 1/6, and then as you go out, they're killing each other off, right? And the negative 1/9 would cancel with the next one. See, the problem right now, though, is that we go to infinity, right? So don't you always have like something appearing and then disappearing and appearing and disappearing? So here's the way we're going to deal with this to try and figure this out. Right now, what I'm realizing is that I'm getting some cancellation to occur. Now, this was called a collapsing or telescopic series. The way you can look at it is, I always looked at it like a bridge. You have the beginning of the bridge over here. The end of the bridge is over there at infinity. What's happening is stuff in the middle is collapsing out. Okay, they're collapsing. Or you can look at it like a telescope, the ones, the old school ones that pull out, right? And then you put them back together. They go like that, like a telescope. That's what's happening. Everything in the middle is going away, so you're telescopic. The two ends are coming together. Got it? Now, here's what we have to do. We have to kind of do what we did with geometric series. We have to look at this. What did we call that? What was that called? S sub n? That was the what? That's the nth partial sum. It's the addition of just the first n terms. Could you do this with me? Would you mind adding up the first n of these guys again? So we know this is 1/6 minus 1/7 plus 1/7 minus 1/8 plus 1/8 minus 1/9 plus dot, 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 right? Keeps going and going. But it stops this time, right? Where does it stop? At n. So I'm going to way over here on the back side, I'm going to put, what would you get if you plugged in n? This is what you get if you plug n in right here. What is it? 1 over n plus 5 minus 1 over n plus 6. That all right? Now, what would the one right in front of it be? You're plugging in n minus 1. Right? 1 less than what you just plugged in. So can you plug n minus 1 into the formula and tell me what you get? 1 over n plus 4 minus 1 over n plus 5, right? Look, I'm doing n minus 1 in right here and right here. And when I do that, I get n minus 1 plus 5 is n plus 4. N minus 1 plus 6 is n plus 5. Do you all see that? And I could keep going backwards, right? But I have enough to see the pattern. I had my 1/7 cancel, my 1/8 cancel, my 1/9, and there's going to be the 1/9 there for it to cancel with. And I keep going. What about this one right here? 1 over n plus 4. Will it get killed off? Yes, by what? The one right before it, right? What about this one? Gone with this one. What about this one, though? It stays. It stays. Right? Because I stopped my sum, didn't I? I stopped it at some place. So here's what we've got. We've got S sub n is equal to 1/6. That was that first term that never got canceled by anything. And then minus 1 over n plus 6. Where's the minus in front? Yeah, because that's in parentheses. So, all right, this is the nth partial sum, right? I don't want the nth partial sum. I want the infinite sum, don't I? And we said last class, it's on your notes here, bottom of, I think it's the first page. Yeah, look at the first page of series. On the bottom it says, a series converges and has a sum S if the sequence of partial sums converges to S. In other words, the infinite sum equals S if what? The limit as n goes to infinity of S sub n equals S. So I want to take that limit and see what I get. Take the limit of that formula. Just 1/6. Everyone's comfortable with why that's 1/6? This goes to 0, right? 1 over n plus 6. 1 over infinity goes to 0. The only thing left is 1/6. Which is kind of what we knew before I did all this, right?
Yeah.
Like we knew it was 1/6 and everything kept canceling. But you cannot do that on the test because you'll get into trouble, as you'll see on another example. So the answer is that this sum is 1/6. So here's my final answer. Sum k equals 1 to infinity of 1 over k plus 5 times k plus 6 equals 1/6. It was a collapsing series.
Why did it collapse in
Everything in the middle went away,
Okay.
right? So, like I said, two ends of a bridge, the bridge collapses. The only thing left are the two ends of the bridge.
So when you're doing the last one, we have to get the SN and then take the limit of the SN, right?
Yes. Yep. But you have to get that S sub n.
Or you go back on top of the bridge. So that
Yes, I am, but after I do this next example. I'll do it at the end if I got some time. All right, look at this one. Find this sum. K equals 2 to infinity. Natural log 1 minus 1 over k squared. I want us to find that sum. That series is definitely not geometric. It's definitely not harmonic. Nth term test, or kth term test, however we want to look at it. What happens if you let the inside, just look at this in here, take the limit as k goes to infinity of natural log of 1 minus 1 over k squared. So 1 over k squared, that goes to 1 over infinity, that's 0. 1 minus 0 is 1. Natural log of 1 is 0. So the nth term test tells us what? That's right. Inconclusive. Which leaves me with the only other thing I've talked about today, which is telescopic or collapsing. So maybe it'd be worth it for us to write out some of these terms. Let's look at the first thing. Plug in, actually look at where this series starts. It starts at 2, doesn't it? What's natural log of 1 minus 1 over 2 squared is 4. So it's natural log of 3/4, right? Plus natural log of 1 minus 1/9 plus natural log of 1 minus 1/16 plus dot, dot, dot. Do you see any possibility of canceling here? The stuff that's trapped in the logs, you can't combine those with these things, right? They're all trapped in their own logs. So everything is going to be a number and you're going to be adding them up. So there's no collapsing happening here, just like in the previous problem. Remember? Before we did partial fractions, it was something plus something plus something plus something. We never had anything subtracted, did we? Until we did partial fractions. Yes? Can't do partial fractions on this.
when you add these up, right, you can use log properties to combine them, and they get just bigger and bigger.
You could use some log properties. Absolutely. Which ones?
They have the same base, so they're adding. So
Can when you put two logs together through addition, can you put them into one log? Make it multiplication? You could do that. What are the properties? I hope they're not too far and you're off.
1/3.
Remember this property. That's a property of logs. This is a property of logs. Right? You have more, but so we're kind of in a jam here. Let me look at this. Let me go back to the original problem. Tell me if you agree that this is this. Common denominator? Right? And now can't I use this blue property right here? and rewrite that as natural log k squared minus 1 minus natural log k squared.
And the square come out for the second term?
It could on the second one, but you might run into a little bit of trouble if you do that. Only because, well, I don't know. I mean, it may work out that way. That you pull that 2 out and it will work. I'm going to keep it there because I'm wanting things to cancel, right? So I'm hoping that somehow when I start plugging in values here, they'll cancel. If I pull that 2 out, it may not cancel. I could also turn the k squared minus 1 into what? K plus 1 times k minus 1, and then split that into 2 logs. Couldn't I? Let's just see what happens, though, right now. Let's take that and see what our series would look like and see if we get cancellation to happen. Sum k equals 2 to infinity of natural log k squared minus 1 minus natural log k squared. Okay, let's try that. See what we get. So start with 2. Plug in 2, you get natural log what? 3. Minus natural log, now plug in, so natural log 4. Okay. That's what I get when I plug in 2, right? Now plug in 3. So plus natural log 8 minus natural log 9. So far, nothing is canceling, right? Plus, now plug in 4, natural log 15 minus natural log 16 plus, is anything canceling? Nothing, right? Y'all see that? Nothing's canceling here. Yes.
Like the first term, right? The ln3.
Yes.
It's the second term. It's the cube of the second term, ln9, because ln3 is 3 squared. And the
Yes.
first term, ln4, is the second term, the third term cube because it's.
I got you. I got you. I got you. I'm with you. There is some stuff that looks like it is related.
And I think it's gonna repeat.
It will repeat. It may be challenging for us, though, to try and figure out what that is.
Would it be like ln 3/4 and ln 8/9 and then it would be like that?
Yeah, 3/4, 8/9. So you could rewrite it that way, but then those aren't going to cancel because they'll be added together. So you'll never get cancellation. What I'm trying to illustrate first is that, okay, I took the natural, I put it together, I got a formula, and now I've got something where I've got minuses now, but nothing appears to easily be just like falling out, like we had in the last problem, right? So what I'm going to do is I'm going to kind of go question mark. I'm going to take this, I'm going to do a little bit more work on the formula using some more properties of logs. We said that this k squared minus 1 in here could be written k plus 1 times k minus 1. And anytime you have two things being multiplied inside of a log, you can split it into 2. So it could turn into natural log k plus 1 plus natural log k minus 1, right? Minus natural log k squared, but I'm also going to take that 2 power and pull it out. That was another property of logs. Remember we had a power in a log? You could pull the power out front. So I took this 2 out here and I dropped it out front. Any questions on where I got this formula? Sure? Now let's try again. What would you get? A couple of these terms. Plug in 2. You get natural log 3 plus natural log, careful, natural log 1 minus 2 natural log 2. All right, that's what I get when I plug in 2. Now plug in 3. So plus natural log 3 is going in, so 4 plus natural log 2 minus 2 natural log 3. Yay or nay? Do we have anything canceling here? I have some common terms. Look at this. This is a natural log 3, right? And I'm taking away
Basically, the other
2 of them, right?
make that ln squared. It's the same as the one before.
Yes,
You just put the 2 down.
that's right. Keep going, though. Keep going with this formula. Let's go with the next. I'm going to plug in what now? 4. So I have natural log 4 plus natural log. Where are we? We're at 4. I've got 4 fingers. Natural log 5, and then 3, and then minus 2 natural log 4. Holy shit, look at that. Look at another natural log 3 popped out. So I have the natural log 3 from the beginning, the natural log 3 from there, and that gets killed off by the negative 2 natural log 3 there. Wow. And then what about the natural log 4s?
Yeah. And then,
It's going to be the same pattern, but I got to see more terms to see it.
no, the 4 gets canceled with the negative 2 natural log 2, right? That turns into natural log 4, which cancels with the first term, natural log 4 here.
You could use that one, yes.
Yeah, those 2 cancel.
The point is, right now, that it appears I'm starting to get the cancellation, right? Things look like they're starting to fall out here. So since I see that now, I need to do the nth partial sum. And it's going to be tough because I'm the page. I'm going to have to go to a smaller pen. So if I start adding up, it'll be natural log 3 plus natural log 1 minus 2 natural log 2 plus natural log 4 plus natural log 2 minus 2 natural log 3. I'm just rewriting what we just had. Natural log 5 plus natural log 3 minus 2 natural log 4 plus, keep going. Natural log 6 plus natural log 4 minus 2 natural log 5. I'm going to keep going because what I'm trying to do is get enough pattern here that I'll be able to come up with a final formula. Wait a minute, where am I? It's 2, 3, 4, 5, 6.
Yeah.
6, yeah, thank you. All right. Is that enough to try and get some pattern? Pay attention to what I'm saying here. I'm looking at the first term in the first set of parentheses, right? Natural log 3. That natural log 3, first term, first parentheses, along with the last term of the second parentheses and the second term of the third parentheses, those 3 together are gone, right? Yes? Those 3 together are gone. So what it took to make one of those terms go away, the first one from the first guy, the second one from the third one from the second parentheses, and the second one from the third parentheses. All those together cancel. Does it happen again for the next one? So go to the next parenthesis. Does the natural log 4 cancel with the third one from the second and the middle from the third? Do y'all see that pattern? That's what you have to find. Does it happen with the natural log 5? The natural log 5, the first term from the first parenthesis, the last term from the second parenthesis, the middle term from the third parenthesis. This pattern is going to continue, right? Right? So let me see. This, how about this natural log 6? Will it cancel? Yes, because it's going to cancel with first one from first parenthesis, second from the third from the second parenthesis, and then the next parenthesis, the middle one, right? Okay, so I'm going to cancel it out. How about the natural log 7? It will cancel as long as I have 2 more parentheses after this, don't I? It'll cancel, okay? But what about these guys? Look at the natural log 1. That's 0, right? But let's just act like it wasn't. What cancels second terms in a parenthesis? What cancels it? What do you need? Go back to the first one we did. The second one, right? You need to cancel the middle guy, right? You needed the 2 in front, didn't you? For this middle guy, there is no 2 in front. So he's not going anywhere. And what do you need for the last guy to go away? The 1 in front and the 1 behind, right? You see that? So this guy right here, I need the 1 in front and behind. But I have the 1 behind, don't I? So this and this are going to go together, but there's nothing in front. So it's not, these aren't going to completely cancel. This one's gone. But these two together don't completely wipe each other out because you don't have the 1 in front. Do y'all get that? So those two together become a what? Negative natural log 2. That's because that's 0. Yeah, sorry, I didn't say that. That's 0. Now, what I'm still missing from my formula for S sub n is all the crap at the back. Right? How many should I write? How many craps at the back should I write? 3 of them. So I can convince myself of the cancellation. So what I'm going to do now is I'm going to go to the back of the sum, plus ... and then I'll do it on the next line. The last term, what would the last parentheses be? We're plugging in n, right? So natural log n plus 1 plus natural log n minus 1. I'm doing the nth partial sum. 2 natural log n, right? That's what the very last one would be. The one right before that is what I get when I plug in n minus 1, right? So what do you get when you plug in n minus 1? Natural log n. We're just basically taking 1 away from each of the guys over there, right? So natural log n plus natural log what? N minus 2, and then minus natural log, or 2 natural log n minus 1. 1 more should be enough to show the cancellation. Natural log n minus 1 plus natural log n minus 3 minus 2 natural log n minus 2. And then plus in front of that ... the other way, right? Yeah, let's verify this. This first one, this last one, and this middle one go away, don't they? Now, this is super important. You catch this last piece of information. How about this one right here? In order for a middle guy to go away, what did we have to have? the 2 before it, didn't we? Do we have the 2 before that? Yes. So that one should go away, shouldn't it? But you can't be canceling things just, yeah, I'm just going to cancel them. You have to understand what cancels it. So that goes away because the 2 before it exist. Okay, how about last ones? Last ones need the one before it and the one after it. This one has the one before it and the one after it, doesn't it? So it's going to go away. Where's the one after? Right there, right? That one? Now I have the natural log of n, which is a first guy. First guys need what? The 2 after it, but I only have 1 after it, right? So it's going to go this one and this one together, which gives me a what? Negative ln. Okay, so these 2 are taken care of, but they go together to become something. And the other 3 we had, how about this one right here? First guys need what? The 2 after it. And I don't have the 2 after it, do I? So he's staying too, right? So the ones that are here, this guy's here, this one's here, and then what did we have from the very beginning? Negative ln 2, right? So, I need a new page. You all ready? I can come back to this after class. I need to finish this up. S sub n, yes?
Can you just go back, because I think the ln minus 2ln is not ln. I think it is something else.
Why? I have an apple minus 2 apples is 1 apple, negative 1 apple.
Oh, yeah.
Right? I mean, you could write it as natural log of 1 over n or n to the negative 1. You could, but it is also that, right? Are you trying to bring that 2 back up? And yeah, you could do that, but. All right, so what did I have? In the front, negative natural log 2 plus natural log n plus 1, and then minus natural log n. And what I'd like to do now is take the limit as n goes to infinity of this. Because of time, I'm going to just write that, because what happens is when you let n go to infinity on the 2 in yellow there, those both go to infinity. So you get infinity minus infinity, which is indeterminate. But then you use the property of logs to put them back into a division, right? And then in here, this is infinity over infinity. Do L'Hopital on that, you get 1. Natural log of 1 is 0. So ln 2 is a constant. So your answer is negative ln 2. Collapsing. What's that? Yeah, natural log of 1/2 if you want. Normal? Yeah. These are kind of interesting. Yeah. All right, so your homework, I guess now would be, you can do page 443, and I mean, it's pretty much on that section up through 27. So 9 through 27 odd. And the evens are good, like I said before. I assigned some stuff from 30, didn't I? 30, 32, and 33. Okay, 34 is interesting, but I won't assign it. I believe that the collapsing problems in this section, they tell you it's collapsing or telescopic. Number 25 and 27. So they determine whether the series is convergent or divergent by expressing S sub n as a telescopic sum. Okay. Have a good holiday. Halloween.